Okay, so this is Psych 222. It is Wednesday, January 27th, and we are into chapter 2 of the book. So last time we talked about a few introductory principles to where statistics are used. And in this chapter, we're going to talk about different elements of research and science. Those include such things as observational studies, sampling designs for surveys, and experimental studies, among other things. Now, we're not going to cover all of these topics, and some of them we're going to treat fairly lightly, but a good read of this chapter is a really good idea to get a grasp of all those things. So the book talks about the idea of intelligent data gathering. So before we do any statistics, before we analyze any data, we've got to get that information. And how you get data varies across the goals of what you're trying to do. So important that we specify the objective of the study, survey, or experiment. Okay, any kind of scientific study that you do has to have a pretty solid objective. You have to know why you're doing it. For instance, in the case of the COVID-19 vaccines, well, they were doing studies for the purpose of developing an effective vaccine. It had a very clear goal to it. You have to identify the variables of interest. Okay, what are going to be the primary variables in your study? And then you have to choose an appropriate design for the survey or experimental study. And then you collect the data. After that, you're going to eventually analyze that data and draw some conclusions. So let's look at some of these elements over here. Well, we've talked about polls when we were talking about the general use of statistics. So that's a good section to read over for a good example of that polling idea over here. Now, let's get into some definitions. What's an observational study? Well, an observational study, the researcher records information concerning the subjects under study without any interference with the process that is generating the information. Well, what does that mean? Well, in observational studies, we are not implementing any controls, and that is different from an experimental study. In experimental studies, we are implementing controls and usually randomizing to conditions. So I'm just going to give an example of an experimental study here. Imagine we have participants, okay, those are participants, and we want to study the vaccine, maybe the Pfizer vaccine that was recently popularized for preventing COVID-19. Well, we may take those participants and put some in the vaccine group and some in a control or placebo group. Notice we have control over our participants. That process of random assignment to groups becomes really important. You definitely don't want to put all young people in this group and all old people in this group. You want to randomly assign to groups. It has the features of an experimental study because of that element of control. When we talk about observational studies, we typically don't have this type of control. And we simply have to observe people or whatever we're studying as they are without doing any kind of random assignment. So there's a distinction between those two. Which is generally the best type of study? Well, the gold standard in science is the experimental study. And that's why when we hear reports about the vaccine for COVID-19 or treatments and things like that, all of those things have been subjected to rigorous experimental studies. So we're going to be talking about this throughout the book, and this is definitely the number one when it comes to scientific credibility. We also can identify explanatory variables and response variables associated with the experiment. Now, what's an explanatory variable? Well, let's give an example over here. I'm going to draw down here. Imagine that we have y is equal to x. So I'm going to identify y here as COVID-19. So COVID-19 occurrence, whether you get COVID-19 or you do not, okay? That would be considered a response variable. Now, this explanatory variable would be, in our particular example, the vaccine. Whether you get the vaccine, yes, versus no. So in this example, we're saying, is COVID-19 a function of whether you get vaccinated or not? We can see that this is the response variable because it's responding to whether or not you receive the vaccine. This variable would be considered the explanatory variable, okay? And throughout the book, we will be talking about different explanatory variables and response variables. There's a distinction made between comparative studies and descriptive studies. You can have a read over that. It's not of tremendous importance right now. I do want to mention this idea of confounding variables. Okay. One benefit of doing a study like this, where you have that experimental design, is you're controlling for a lot of those confounding variables. Well, what was one confounding variable that we had up here? One confounding variable would be age, right? Because we know that younger people are less likely to suffer consequences from COVID-19 than older people. So if you do the experiment, you can account for confounding variables like that. If you do not do the experiment and you simply observe who has COVID-19 and who doesn't, then that confounding variable never gets controlled for. So again, that's one advantage to using experimental studies. One important thing to note here is that cause and effect relationships are very, very difficult to arrive at. They're so difficult that even defining what cause means is a pretty deep philosophical question that philosophers of science, they regularly grapple with, and they study that. What does it really mean to say that A causes B? It sounds like it's a simple question, but it actually gets really, really complicated. If you're doing experiments, then you have a better shot at concluding something close to a cause and effect relationship than if you're doing purely observational studies, right? Because why is that a problem? Well, it's a problem because if you see people who suffer from COVID-19 and they happen to be old, you don't necessarily know that age is causing COVID-19. You don't know that simply by observing that pairing. The only way to analyze anything close to that would be through an experiment, but that would be actually really hard because you cannot randomly assign age to people. So studies become very difficult in trying to draw really strong conclusions, as we'll see when we progress through the book. Many times, the best that we can do is talk about these things called associations, right? So they give an example here: high dietary fat content and heart disease. There may be an association between those two things. And oftentimes in the media, those associations are defined as links. So whenever you hear in news reports, you'll hear things like, well, high fat content has been linked to heart disease, right? How often have we heard things like that? They are very, very careful in the way they use the words here. They cannot say that high dietary fat content necessarily causes heart disease, because as mentioned, getting to causation is really, really hard on a methodological level. So oftentimes it's an association or a linkage or some kind of word like that that best describes the scientific result. Okay, there are different types of observational studies. There's the sample survey. We'll talk a little bit about that. There's a prospective study. This observes a population in the present using a sample survey and proceeds to follow the subjects in the sample forward in time to observe them. That's called a prospective study. And then there's also a retrospective study that observes a population in the present using a sample survey and also collects information about the subject in the sample regarding the occurrence of specific outcomes that have already taken place. So we see the idea of retrospective being in the past a little bit, whereas perspective kind of seeing what's going to happen forward in time. Okay. There's the idea of cohort studies and case control studies. A couple definitions there to read up on, be familiar with. I'm just going to talk about this cohort study a little bit. The cohort study is interesting because you can follow a group forward in time to see what happens with them. So for instance, maybe they want to do like a longitudinal study where they want to see the reading ability of those in second grade, right? So imagine they start studying children in second grade and trace them all the way to sixth grade. Well, in that particular case, there's a particular cohort that they are following. Let me give you an example of a cohort that will be studied for years to come, the COVID-19 cohort. And I'm talking about all the school children who have lost some time in school. That cohort may be studied for some time to determine any effects of not being in school because of the COVID-19 virus. So that's an example of a potentially interesting cohort to follow. In case control studies, two groups of subjects are identified, one with the disease and one without the disease. That's an example of the case control studies. They take different forms as well, where you have the identification of groups. And it doesn't have to be two groups. It could be more than two groups that you're interested in studying. Again, the most interesting thing here is definitely that idea of that cohort study. Okay. Okay, let's talk a little bit about sampling designs for surveys. Now, what's a survey? Well, a survey is a method of data collection. So you'd like to find out something about your population, and there's the population right here. That's the group of individuals that you're interested in studying. But there are far too many people in that population. So what you choose to do is you gather a sample of information. Okay, that is a sample of participants on which you're going to collect some data. And maybe you choose to give those people a survey because you'd like to find out about maybe their voting behavior, their food preferences, or a whole bunch of other things. So we identify here this idea of the target population, and the target population is what we are mentioning up here. That's that overall group of individuals or objects, whatever you're studying, that you're interested in knowing something about. Again, the question comes, why don't we just study the whole population? Now, if you want to find out whether people will vote this way or that way, whether they'll vote Democrat or Republican, why don't you just ask everybody? Well, that becomes very, very expensive, right? Giving a phone survey or doing a poll on the whole population would just be infeasible. It'd be too expensive, it'd take too much time. So that's why we study the sample. The smaller set of observations, we study that very well, and then we try to make a conclusion about the population. So that's what this is, the sample. That is a subset of that target population. And one note here is often when we talk about the population, we may not call it the target population. We just may call it the population. And using the word population, it's implied that that's the group that we're targeting. So sometimes target is not used at all. The sampled population, well, this is the complete collection of objects that have the potential of being selected in the sample. The population from which the sample is actually selected. Now, this becomes really interesting here because let's imagine we do a telephone survey and you want to phone people and you want to find out their voting behavior. So are you going to vote Dem or are you going to vote Republican? Well, what's the issue with a telephone survey like that, with a poll? You may think that you're capturing information about voting behavior of Americans, but maybe some people will not respond to the phone. Or if you start calling landlines, so those are those old phones that are connected within the home, well, then you're only reaching people who have those types of phones, and you're not reaching people with cell phones. What other pieces of information complicate the issue? Well, the rest is maybe you're only tapping into people who like to answer phone calls from pollsters. For instance, when I receive a call on my cell phone, if I don't see any ID, I just don't answer it. So if it looks like it's from a random number, I just don't even answer it at all. So if that's somebody calling me to find out whether I'm going to vote Democrat or Republican, they're not recording my information because I've ignored the call completely. And that becomes really, really important to know what population you're actually getting to. It may not be the population you think. And of course, the classic example was in that 2016 election, where the polling was way off, and that was likely due to either people lying about who they would vote for, or people simply not responding and things being biased. So that becomes an important distinction. We need to keep that in mind when we do telephone polling, when we do telephone surveys. We may not be tapping into that population we're actually thinking we're getting to. The observational unit is the object about which the data are collected. So we could be dealing with human populations, we could be dealing with animals. Maybe we're doing a study in Yellowstone National Park and we're studying wolves. Well, each wolf would be considered the unit that we are observing. The sampling unit, the object that is actually sampled. So we want to study wolves, but we're only going to sample a few of them. That's the sampling unit. And the sampling frame here is the list of the sampling units. So for instance, for a mailed survey, maybe a list of the addresses of households in a city. For an ecological study, maybe the map of areas downstream from power plants. That's called the sampling frame. Again, these things become a little bit fuzzy because sometimes you're not quite sure what you're studying. And for instance, in that telephone survey example, it may be very difficult to know what that population is that you're studying. Another example is in psychological studies and many others. Many of those studies rely on the volunteer subject. Maybe you've participated in a psychology study or other study and you've been asked to volunteer for it. Well, those researchers are studying volunteer subjects, right? They would like to generalize their results to people in general, but people in general were not studied. It's the volunteer that was studied. So let's imagine that somebody comes to your class when we're back to normal after COVID-19 and we're having all these live classes again, and that person wants to take a random sample of, let's just make the sample small, 5. Well, if that person asks who would like to be in the study or experiment, and these 5 respond, they are all volunteers. So is there something special about the volunteer subject that might actually have an impact on your outcome variable? If so, then you cannot draw the conclusion about people in general, you can draw the conclusion about the volunteer type subject. And that's really important to keep in mind. Simple random sampling. This is the process usually performed when collecting data from a population. We want to do it randomly. Now, why do we want to do it randomly? Again, there's my population. If I'm collecting data from it, I definitely do not want to, walk around the population and select certain people for the study based on certain characteristics. That would bias the study. So it's important that when the sampling takes place, that there's some kind of random mechanism that will select the participants. Now, that doesn't guarantee that the participants we do select will not all share a similar characteristic. It doesn't guarantee against that, but it helps. So simple random sampling is usually our best shot at trying to get some kind of representation of the population. So there's our sample, and it should be collected oftentimes by simple random sampling. We'll talk about these things later in the book when they come up, so we're going to skip those for now. You can have a read of them, but we'll talk about them more as we go. Same thing with systematic sample. Again, reading over that would be a nice idea, but it's not of paramount importance right now. We've talked a little bit about the problems associated with surveys, survey non-response. And again, that was the idea that maybe some people just don't like to answer their phones. Well, if they don't like to answer their phones, you're not getting that person's data. And maybe that piece of information would have been very important in your experiment, in your survey. Measurement problems. Well, measurement problems are the result of the respondents not providing the information that the survey seeks. Imagine that, right? People are not always honest. People may not understand the question that you're asking. People may give a socially desirable response, right? So all of these things play into data collection, and this is very, very important. Now, there are courses in an area called psychometrics in psychology that discuss these things in great depth. And the whole course is centered around measurement. In psychology, measurement is a really, really important thing because psychologists want to measure attributes that are not easily measured. Let me give you an example. We all know how to measure weight, right? We all know how to measure weight. For instance, we get on the scale in the morning, we can measure our weight. Very few people would disagree with how weight is measured. If you told somebody that you got on the scale in the morning, they wouldn't say, wow, why are you measuring your weight that way? That makes no sense to measure weight that way. Nobody would say that. We all agree with weight measurement. The same is not true when you talk about things like IQ. And IQ is something that people like psychologists would like to measure. But this is much more controversial. IQ is much more controversial, to the point where some people would even say that measuring IQ is kind of like a silly idea, that IQ cannot be measured, and maybe there's no such thing as IQ. So there's people who even disagree with it to that extent. Other researchers will think that an IQ test is simply insufficient for measuring IQ. And there are a lot of issues with IQ tests, including there could be a culture bias. For instance, if you give the IQ test to a person in one culture, is that the same thing as giving that same IQ test to somebody in a different culture? So it could be culturally biased. So what does that score actually represent? So if somebody scores low on the IQ test, does that mean they possess very little of this thing called IQ? Or does it mean that they're being biased because it's not culturally representative? So there's a whole bunch of issues when we talk about measurement. Measurement is a very, very difficult problem, especially in fields like psychology, economics. It can be very difficult as well. For example, when you think about things like the unemployment rate, right? We hear about this on TV all the time. What's the unemployment rate? Well, how are they measuring that exactly? Is it the people who do not have jobs? Is it the people who are trying to find work? Well, how do you define trying to find work, right? That becomes very, very difficult to measure. So measurement problems abound in the sciences, and they can be very, very difficult to solve. The key takeaway here is before you do any statistical analysis, before you do anything with data, make sure that your measurement instrument is very, very sound. Cannot emphasize this enough. And this holds true now and as you go forward. If you go to graduate school, the measurement problem is what you should be mainly focused on. Okay, so here are some examples of problems that the book mentions. You can read up on those. Just one example here, just to talk about this, leading questions. Sometimes if you ask questions in a particular way, it can promote a given response, which is not a good thing for measurement, right? Imagine if I asked you the question, why are you always happy, right? If I said, hey, why are you always happy? Well, that may lead you to think that you are always happy, which maybe you're not. And that type of thing, it's a little bit of a leading question. And those of you going into areas like clinical psychology and counseling, you'll learn in those areas that leading questions are not always a good thing. So trying to elicit a response from an individual is not always effective. So we have to be aware of that when we construct surveys and collect data. Unclear wording of questions. We've touched on that a little bit. You want to make sure the questions are very clear. And again, this book is only talking about measurement in a couple pages. In a psychometrics course, you'll talk about measurement for the whole course pretty much. So what are some data collection techniques? Well, we've talked about questionnaires. Here's a stages of a survey. So questionnaire, survey, this gives a whole bunch of things, that the line of progression for obtaining survey information. This isn't vital to know, but you can read that to see what a sample flow chart looks like for that. You prepare the questionnaire, it goes through some revision, data collection, final report, and then you're writing the report. So different steps there. Again, that's not very vital. Data are frequently obtained by personal interviews. Okay, so you can also use those for data collection. It's not exactly very scientific. I mean, you can rigorize personal interviews, but if you're just doing a casual interview of somebody, that isn't very scientific. So we need to be aware of that as well. Just asking people, you know, how are you today? In terms of measuring things like depression, do you feel depressed today? Those are not very scientific. You'd want to get a little bit more rigorous. Nonetheless, personal interviews are sometimes used in data collection. They're especially useful in counseling situations where you want to collect information about the client you're counseling. So in those respects, they can be very, very useful. We've talked about telephone surveys. You can read more up on that to hear what the book has to say. The self-administered questionnaire, we see these online a lot, and most questionnaires online are not very scientific, so you cannot take the results very seriously. But sometimes questionnaires are mailed or sent through email to participants to fill out. But again, those can have issues with them. So we have to remember that not all information that's collected is necessarily good information. And there's nothing worse than that quiz online that is not scientific and is providing misleading information. So you can't trust those results. Sometimes there's a very, very low response rate. So if you send out questionnaires to people, let's say you send out 100 questionnaires and only 20 come back, right? Well, again, you're studying people who like questionnaires, right? People who like responding to questionnaires form the basis of your studied sample. What about those 80 people who did not respond? Well, they have data too. It's just that that data is not making its way into the study. And you have to keep that in mind, that your sample here becomes very, very selective. Direct observation is an excellent way of gathering data. And some purists would say, well, it's the only way to get really, really good information on human beings. Let me give you an example. If you use a self-report, okay, if you use a self-report questionnaire and you ask people, let's take up a trivial question here. You ask people, how much do you like pizza? Okay, do you like pizza a lot? Do you like pizza a little bit? And you ask them to rate it on a scale. So let's say we go from 1, 2, 3, 4, 5, where 5 is most and 1 is least. Let's say that some people respond 3, some people respond 4, etc. Well, that's a self-report on pizza liking behavior, right? But there's some problems with that because maybe some people just like to answer 4 and 5, whereas some people like to answer 2s and 1s. It's entirely possible that the person answering 2 actually likes pizza more than the person answering 3. You cannot simply look at the numbers on that self-report and assume that those differences always represent differences in pizza liking. Okay, that's important. What you're seeing on the questionnaire is that some people circled 2 and some people circled 3. That's the only thing you're genuinely seeing on the questionnaire. Does it indicate true pizza preference? Well, how would we validate that, right? How would we actually confirm that differences on the scale correspond to differences in actual pizza liking? Well, one way would be direct observation. Observe your participants. Do they eat a lot of pizza? Do they not eat a lot of pizza? That would be a really good measure to see if they actually like pizza, right? Or at least have them self-report on how much pizza they had that week. Because if you simply ask, do they like pizza or not, you may get an inaccurate result. But if you go directly to the observation and measure it, such as how much pizza have you had this week, you may get a better measure. Sometimes direct observation are used in observing the play of children. For instance, you may have a psychologist observe the play patterns of children, and they're not influencing the play patterns of children. They're simply watching the children play. So the children are unabstracted by the observer, and you can just see what they're doing and get that direct observation. So that's very, very important. In the history of psychology, for instance, behaviorism, popularized by folks like B.F. Skinner. If you haven't heard about B.F. Skinner, you will in psychology courses. B.F. Skinner was a big believer. Skinner was a big believer in observing the behavior of things like pigeons and other animals and human beings. And somebody like Skinner would argue that direct observation is really the only way you're going to actually learn about behavior. Okay, as mentioned, the classic, most rigorous way of accumulating knowledge for many things is the experimental study. And we've talked about that idea of the experimental design in terms of the vaccine, but that's really the gold standard when it comes to research. Now, we've all heard Dr. Birx and Dr. Fauci on TV since the pandemic began. People have been asking these experts, how are we going to know whether we have an effective treatment or prevention of COVID-19? And you may recall that early on the pandemic, there were some hypotheses given out as to what would be a good treatment for the virus. Well, what did Dr. Birx and Dr. Fauci keep saying? They said, until you see the experiment, you just don't know whether something's effective. And again, just to stress this point, let's say that you believe that a given pill is going to be effective at treating COVID-19. Well, you can't simply give the pill to a few people who have COVID-19 and see if they get better. That wouldn't be enough evidence for that. You need to do that controlled experiment where you can control the treatment group to the control group. So if those are your participants, you need to have that random assignment and make that comparison. If you do not do that, and you simply give the medication to a few people and kind of rely on anecdotal evidence, then you're not really doing the best scientific investigation, and you're definitely not doing an experimental study. That's why experiments are really, really important. And as you learn more about statistics and research, increasingly, you're going to want to see the experiment to know if something has an effect. And that works for a whole bunch of things. Not only treatments for COVID-19, but also things like, does aspirin work, right? Is aspirin effective at alleviating symptoms of a headache? Well, how would we find out? We would have to do the rigorous experiment for that. Okay, they just describe here what we've talked about, random assignment and different examples of how you can treat that experimental design. This is the key definition. The designed experiment is an investigation in which a specified framework is provided in order to observe, measure, and evaluate groups with respect to a designated response. And the key element here for the designed experiment is that it is the researcher who has control over the elements of the framework. Again, there's a big difference of observing people who get better from COVID-19 versus doing an experiment where you treat some people with the medication and some people not. Those two things are not the same. That observational study is not the same as that experiment. In experiments, we have factors that are selected by the researcher for comparison. Now, an example of a factor here would be the treatment yes versus no. So if you're trying to treat COVID, well, you have a treatment yes versus no. That's an example of a factor. The response variable, these are measurements or observations, and that's in this case whether the person improves their symptoms from COVID-19 or do they get worse. So there's an example of that. The treatments in experimental study are the conditions constructed from the factors. Well, there's our classic example for the COVID-19 example. Did they receive the treatment? Did they not receive the treatment? Okay. And this is called a treatment design because some people are getting the treatment and some people are not getting the treatment. So all of these things form the hallmark of what makes for good experimentation. And there's an example you can read up on as well. Okay, let's stop there for today. Next time we are going to pretty much finish off chapter 2 and continue with our discussion of experiments and get further into how statistics are used to evaluate data. So that's it for today, and we will see you next time.